Hi guys, very good morning officers, good morning friends. So again, we are continuing the quick mastery classes for mains, for prelims and mains. And this sessions we would be discussing all the topics, but we would be discussing the overview of all the topics. We would not go into depth. That would be in another session. We would be discussing overall topics in one go, and we in the last classes we have finished discussing geomorphology and we entered into climatology. And climatology we have started discussing lot of topics, and the last topic we discussed was humidity, clouds and precipitation. Good morning again. So let me remind you guys, this is a two-way communication class. I would like you guys to ask more questions where I would get chance to explain more, and don't make it a one-way communication class which usually gets boring. So is that okay, friends? Christina, JK, Palak, Rimin. Okay. So we in the last class we discussed humidity. So simple definition of humidity would be the amount of water vapor present in the atmosphere. And we know that uh, why should we study about humidity? Why do we need to know about water vapor? That's the first question we have to ask. So water vapor is a variable gas in the atmosphere. Variable means it varies from 0.2 to 4% in the atmosphere. So maximum variation occurs in the case of water vapor, right? And why do we need to study water vapor? Can you guys tell me, why do we need to understand humidity? Why do we need to know how much water vapor is there? To predict the rainfall, right? That's the main aim of studying of climatology, to predict rain, where, when, is there a possibility? Okay, so the first method to calculate humidity was absolute humidity. Absolute humidity, we take care of the actual water vapor. For example, I take area 1 cubic meter of air. How much grams of water vapor is present in 1 cubic meter of air? We call that absolute humidity. Simple definition. So you take a 1 unit of air, and in that 1 unit of air, how much grams of water vapor is present? That is called as absolute humidity. Is that clear, friends? Okay. Then absolute humidity was not helping us to understand whether it will create rainfall or not, because different air at different temperature can carry different amount of water. So just knowing how much gram of water vapor is there, we cannot predict rainfall. For that, we needed a new method for calculating humidity, and that is called as relative humidity. And this is what we use the most to calculate humidity. Can anybody tell me what is relative humidity? Uh, Not exactly. Very good, but you're very close. So let's move ahead and understand relative humidity. Okay. So the first point you have to understand, at a particular temperature, air at a particular temperature can carry a particular amount of moisture, and the same air parcel at a different temperature will carry different amount of moisture. It can carry only different amount of moisture. So the amount of water vapor that air can carry depends on the temperature of the air parcel. This is the first point you have to understand. Okay. So now let's please guys, just a second. Now imagine this is the windward side of a mountain. Okay. Can you see air is blowing from this side? So it will start rising up the mountain. Okay. Now, this air parcel at this point, when it reaches here, let's assume the temperature is 30 degrees Celsius. And at 30 degrees Celsius, the water vapor that this air parcel, which we are considering, can carry this much amount of water vapor. Maximum amount of water vapor it can carry is this much. Okay. Now, imagine the water vapor there is only 1/4. So 1/4 of it is filled with water vapor, but it can carry 3/4 more. So we will say that the relative humidity of this air parcel at 30 degrees Celsius is 25%, because it can carry 100 units at 30 degrees, but it is carrying only 25 units of water vapor. So we say that the relative humidity is 25%. Now, when the air rises up the mountain slope, what will happen? The temperature will decrease. Very good. So, when the temperature decreases from 30 to 20, what happens is that the carrying capacity of the air will reduce. A smaller box. So this was a bigger, here the air parcel can carry more water vapor, but there is only 25% of water vapor in it. Now, as the temperature decreases, the carrying capacity of the air decreases. Okay. So here it was 25%. As the carrying capacity has decreased, now the water vapor is covering almost 50% of the total carrying capacity. So at this point, we say the relative humidity at 20 degrees Celsius of this air parcel is 50%, because it can carry this much, and half of it is carried. Now, again, when the air rises from 20, we are just taking examples. So 10 degree, the temperature goes down. Now the carrying capacity has still gone down. The air can carry only this much water vapor, and this water vapor is filling, it's fully saturated. So at this point, we call 100% saturation. So this understanding is called as relative humidity. Okay. Uh, the capacity of saturation, so we say capacity of carrying water will decrease with temperature when the temperature decreases, and when it comes down, the opposite happens, and the temperature increases, the carrying capacity of the air will start increasing. And that is the reason why there is no rainfall on the leeward side of the mountains. Not because there is no water vapor, because there is water vapor, there is less water vapor, but the carrying capacity of the air increases. Let me explain that part also if you want me to. So, when you talk about the air climbing down, here we said it is 100%, right? 100% relative humidity at a particular temperature. Now, when the temperature goes down from this point is called as saturation point. And from this point, when the temperature starts going down, rainfall, the clouds will start precipitation. Now we go reverse. Here it was 10 degree saturation. Okay. Now when the air comes down 20 degrees, the carrying capacity has increased and the water vapor is only this much. So a bigger plastic cover with less water, water cannot spill out. Again, it comes to 30 degrees Celsius, the carrying capacity again decreases. So relative humidity will still be lower. So this is why we don't get rainfall on the leeward side of the mountains. Online friends, all okay with this topic? Come on guys, this is not a usual class where you guys all sit quiet. I would love to see you guys switching on your cameras if you're comfortable, but reply, I would like you to say yes, no, or something else. All okay, friends?
Yes, sir, yes.
Thank you so much. There's one person who's responding. Please don't type in the chat box. It would be very difficult for me to read it. Better you can unmute and speak up. Okay, done? Okay. Now, the next topic we are going, we'll go into detail. All these topics we'll be covering in detail when we do the second level of learning. Now, we are going in an overview mode. Okay. Then we have clouds. Now, can anybody give a definition of a cloud? It is a collection of water vapor, dust particles, which is suspended in the air, right? Yes. So, how does cloud formation happens? When water vapor rises, it cools and it condenses and form clouds. Simple. It's a mixture of water vapor, ice crystals, dust particles, all these together forms clouds. So, are cloud necessary for rainfall? Yes. Without cloud formation, there cannot be rainfall. But every cloud will not give rainfall also, right? We have seen many clouds, they pass by, they don't give rainfall. But for precipitation, clouds are compulsory. Great. So, let me come to this slide before I'll show you here. So, naming the cloud, right? You know my name, right? I have two parts, Sundaram, Ganesh, SG. So, same way, cloud also has a two-part naming. They have a name and a surname also. Okay. So, name, the first part depends on the height of the cloud. Imagine if the cloud is from the ground level up to 2 kilometers, the first name would be strato. So, if the cloud is in the range from the ground up to 2 kilometers, we call it strato. Strato. Oh, stratus is different. We'll come there. This is strato. Done? Now, second naming part is, if the cloud is from 2 to, some books say 5, some books say 7, 2 to 7, the first name would be alto. So, strato, second name is alto. Okay. Now, if it is more than 7,000 meters up to 12,000, or we say we have studied, right, 95% of the cloud formation happens inside the troposphere. That is why we call troposphere as the weather layer. There are some clouds in the stratosphere. We can see cirrus cloud. Okay. So the clouds on the highest range, we start their name with cirro. So strato, alto and cirro. These are the three words that can come in the first part of the name. And that, what does it shows? Height of the cloud. Now, the second name shows the shape. The second name shows the shape. Okay. Imagine you have seen sometimes when you see, usually people nowadays don't even look up the sky, right? Can you imagine when is the last time you saw the moon for 5 minutes patiently? That's lucky. But usually people don't even watch it nowadays, right? We don't have, we are busy with our phones. Think how sad it is if you have not seen the moon properly for the last 1 month or 1 year, then there's something wrong with us. Okay. So, when you see the sky, if you can see that the entire sky is covered by a thin layer like a bed sheet, a thin layer of cloud, entire like a bed sheet cover, like a shamiana. Such cloud, such shape of cloud, we call as stratus. Strato is different, stratus is different. Stratus cloud means like a bed sheet, like a single layer of cloud. Stratus. Okay? Online friends, all okay?
Yes, sir.
Great.
Yes, sir.
Lovely. And I would also request you, again, there's no rules and I don't make rules one-sided. It would be nice if you guys can switch on your cameras. I can better understand expressions, where I should pause, where I should fasten up. So it's a request from my end. Okay, stratus. The second shape is the one we keep drawing from our childhood. This is called as cumulus. 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 Stratus, cumulus. Okay? And something like a wisp of hair. If the clouds are of this shape, we call them cirrus. Height is 0. Shape is cirrus. So don't get confused. If it's like a wisp of hair, if you a girl's hair is lying like this, like a brand of hair, such shape is called as cirrus. So the clouds would be named first part based on their height and second part based on their shape. And I would encourage you guys to ask more and more questions so that I also get to explain more. Any questions? All okay. Lovely. Now, again, there is one more word which we have to understand. Okay, before that, you guys wrote this out, right? So, clouds in this lower layer we can call them as stratocumulus. Stratocumulus. So, strato is the and cumulus is the shape. Okay. Here it comes to altocumulus or altostratus. Cirrocumulus, cirrostratus because of the height. So these are the combinations that are possible. Okay. Okay. Any Harry Potter fans here? No? You would have heard the nimbus. Yeah, it's the broomstick, fastest broomstick, nimbus. So the word nimbus in cloud tells that the cloud is dark in color and there is a great probability of rain. So nimbus clouds, the word nimbus stands for rain bearing clouds. The word nimbus stands for rain bearing clouds. All okay? So in the mains, if you get a easy question like this, explain how clouds are named, you can write this explanation. Okay. Now let's go back to the slide and see the names. So cirrus, high. Cumulus, like a cotton candy, right? Stratus is flat. And why would you want to learn these things? What is it useful? Imagine you're walking with your girlfriend or a boyfriend, right? And suddenly you see a cloud like this. And after some time, you see the cloud growing upwards. The cloud growing upwards. Now, what will I do? When I come down, I will say, I'll open my umbrella. So, my friend will ask, why are you opening an umbrella? It's not raining. Then, 1, 2, 3, rain falls. So you understand from the cloud that it can rain. And if the cloud is a stratus cloud, we can understand the air, there is no upliftment of air happening and there is no chance of rain there. Okay. So when a cumulus cloud grows upwards, it shows that the air is rising upwards. And we call such atmosphere as unstable atmosphere. There is a chance of rainfall. Such kind of atmosphere we call as stable atmosphere, no chance of rain. Okay? Done? Shall we move ahead? Okay. So, you guys understand one thing. For precipitation to happen, you require air to move upwards. Am I correct? Online friends? Hello. If you guys
Yes,
don't,
sir.
yeah,
Yes, sir. Yes.
yeah, if you don't keep saying that, I feel that you guys are watching cricket, India, Australia cricket match, right? So keep responding. Okay. So precipitation. So the first condition is that air should rise. And only if air rises, there can be condensation, cloud formation, and there can be rainfall. That's clear? So now we are going to study a small topic called as types of precipitation. Precipitation types. Types of precipitation. Okay. So when you are writing types of precipitation, put an arrow and write down forms of precipitation is different. Both are different types of precipitation and forms of precipitation. Students usually confuse between these two. They both are different topics. So now we are going to study types of precipitation or precipitation types. Okay. So precipitation types are divided into 4 types, and the division is based on why the wind is rising upward, the cause of the wind to rise upward, that cause, based on that cause, we have classified types of precipitation. So types of precipitation, on what basis are we classifying? We are classifying on the basis of what is the reason that is making the winds move. Okay. Now remember, we studied troposphere, stratosphere and all. What is the base of classification of these layers, my dear friends? Huh? I think we discussed that in the class in our previous slides. We discussed what is the base of classification, where we divided the atmosphere into troposphere, stratosphere, mesosphere and all. Not height. Huh? Imagine we told a story, we send a student upward in a balloon and the student was measuring temperature. Very good. The classification is based on temperature. And we had discussed that in detail, right? Again, a message to all my dear friends. Studying is not at all useful until and unless you revise it 5 to 10 times. You'll forget everything. That time you understood the concept. But now I asked a question, we were blank for some time. You could get it, but that is the secret of UPSC. People study a lot, go there, and in prelims they don't remember anything, and they come out with a failed status. So it's more about revision. I if I would say, in rather than reading 80% of the syllabus once, it is enough you read 30-40% syllabus, but you read it 10 times. That's a better way according to me. Okay. So, types of precipitation. The first type of precipitation we are going to study is convectional precipitation. So, the first type of precipitation is convectional precipitation. Convectional precipitation. Okay. So, convectional precipitation, very, very basic, happens mostly in areas where you get lot of sunrise or sun, where sun is maximum. So, we could talk about the tropical regions, right? So what happens? The land gets lot of sunrise in the morning and the daytime. It gets heated up, and when the land gets heated up, it heats the air particles near it, and these air particles, when get heated up, start rising. When they start rising, they form clouds, and this can cause precipitation. So such a type of precipitation is called as convectional precipitation. So how will you make your notes? Write down convectional precipitation. Land gets heated, air above the land rises up, causing rainfall. Okay. So where would convectional rainfall usually we can see? Mostly we can see it in hot regions, equatorial areas or tropical regions. Very good. The second type of rainfall is, or types of rainfall, the second one is orographic rainfall. What can you make from this word orographic? Don't think of Oreo. It has nothing to do with orographic. What do you mean by orographic rainfall, my dear friends, online friends? Please make mistakes, but try. So when you make mistakes in the class and people will laugh at you will remember that point forever in your life. You would never make that mistake again in your exam. So, orographic rainfall. Can anybody give me an idea? Huh? Rise and fall of air. So, how air would rise? That's the question. Convectional rainfall, we said the air will rise because the land is heated up and this heat will heat the air and air will rise. Convection. Orographic, the word oro in geography is related to mountains. Orogenesis means formation of mountain. Orolysis is breaking of mountains. So oro, the word oro in geography stands to the meaning of mountains. So now you can guess orographic rainfall is when the air rising is caused by mountains. Right? The best example you can talk about is the Western Ghats. Yeah, how will the mountain help? So, Western Ghats lies like this. So, the southwest monsoon winds coming here, they will come and they have nowhere to go. They will start rising up the mountain slope, right? Causing rainfall on the windward side. We just discussed relative humidity goes increasing and then it comes down. It like the mountains are here, it will climb and then it will come. Orographic rainfall. There is Himalayas, Aravalli ranges lies like this. So the wind travels almost parallel. That is why this area has less rainfall. Yeah, because the mountain is parallel. If the mountain is perpendicular, it can block easily. But the Aravalli ranges lies like this from Jaipur or from Ahmedabad to Delhi, and the winds travel almost parallel to it. So there is less rainfall region there in Rajasthan and Gujarat. So again, winds would come inside India, and we have the Vindhyas mountains and the Satpura mountain which block them, causing rainfall. So imagine if your city has no rainfall, if you can build a big wall like a mountain, it will block and it will give you rainfall anywhere. Orographic rainfall. Is that clear, online friends?
Yes, sir. Yes.
Thank you. Rimin. Okay. So where are you guys from? You're from Maharashtra. Rimin?
Andhra,
Andhra Pradesh. Then
Assam.
Assam. Lovely. Then
Delhi.
Delhi. Great. Nice. So, talking about the neighboring state of Assam, you have Meghalaya, where you have the Garo, Khasi, and Jaintia hills. So, the winds coming in from Bay of Bengal are stopped by these mountains and causing heavy rainfall there, which is recorded as one of the highest rainfall or the highest rainfall region in the world, Mawson Ram, right?
Yes, sir.
Very good. And as I said, the less rainfall region is due to lack of mountains. So see, Gujarat. So the wind is coming in from this side, and the Aravalis lie like this, starting from Ahmedabad to Delhi. So the last hill of Aravali ranges is the Rayasima Hill in Delhi, which is where we have the Rashtrapati Bhavan. Very good, the Rashtrapati Bhavan. So the winds blowing goes parallel, less rainfall. Imagine if you can shift the Aravali ranges and keep it like this area will also become a forest area. Okay, orographic rain. Done. Shall we move ahead? So the first one was convectional rainfall. Second one was orographic rainfall, and third one is cyclonic rainfall. We'll study cyclone in detail later. We'll go an overview, but right now, cyclonic rainfall. Cyclonic rainfall, we know cyclones are formed in the oceans. We'll study why, where, and when, maybe in the next slide. So now the cyclones originate in the Bay of Bengal, for example, and they are winds that rotate and form a circular path. They move in circular like path like this, right? So how are they formed? They are formed when there is a low pressure on the ground. Low pressure means the air is rising upwards, right? From the ground, if the air moves upward, there is no air here, so it is low pressure. So when there is a low pressure in the ground, air will start blowing in from all direction into this area, and due to the Coriolis force, they would start rotating. And when the air rises upwards, it creates clouds and it creates heavy rainfall. Such kind of rainfall is called as cyclonic rain. Okay? Cyclonic rain. And the last type is frontal rainfall. Write down frontal rainfall. Again, I am saying don't get worried. We are going very fast because we are just covering the names of the topic that would help you study your NCRTs and books. Then we'll go into the deeper session also where we'll explain everything in detail. Okay. So frontal rainfall is there is something called as air masses. Air masses are similar air which are thousands of kilometers long and they move as a complete block. This can be thousands of kilometers or hundreds of kilometers. When you cut them horizontally they have same temperature and same humidity, and they are formed. So they are formed over flat surfaces. When there is flat surface and air is stagnant above flat surfaces, it forms air masses. So frontal precipitation happens around 60-degree latitudes. What happens? Around 60-degree latitude, the cold air mass coming from the top and the warm air mass coming from the bottom or the lower latitudes, they come and meet. So this is the warm air mass, this is the cold air mass, they come and meet. So what will happen? The warm air mass, which is lighter, will start moving upwards. Yeah, start moving upwards. What will happen when the air moves upwards? Condensation, rainfall. Such rainfall are called as frontal rain. Uh-huh. This meeting together or formation? Formation. The formation happens in flat areas like ocean regions or plains or very big plateaus. So if the surface is uneven, the air cannot form a uniform surface. So it will forms on flat areas. Like you said, if there is a very big plateau, yes. If there is a plain surface, yes. Oceans, yes. They form air masses. And they start moving as a complete unit. Okay, good. Online friends, any question till now? No questions? Come on.
Also, can you explain this frontal rainfall one more time? Like how it happens with the wind masses?
Okay, so we will surely study frontal like air masses and fronts as a separate topic. But let me explain here. So you understood air masses are formed. Let's take this is 0 degree, this is 30, or this is 30, 60-degree latitude, and 90 degree. So here we have the formation of cold air masses. The Siberian region, maybe take the example of Siberia, it's flat land. So there cold air masses are formed. And here over water or deserts, air masses are formed, which is warm air mass. Now with the trade winds, they'll move in this direction, they will move in this direction, and they meet around the 60-degree latitude. And when the cold air mass and the warm air mass comes and meets, the warm air mass will start rising upwards, and it will rise upwards creating clouds and rainfall. Such a rainfall is called as frontal rainfall. Did I answer your question or you had something else in your mind?
Yes, sir. So, can you say like air masses are formed by the accumulation of similar temperature of air?
Air masses are formed when the air remains stagnant over a flat surface for a long time. So, ocean, flat surface. If there is no horizontal movement of air and air is stagnant over the ocean for a very long time, uh, the quality of the ocean would be transferred to the air and it becomes an air mass. And if you cut the air mass horizontally, you can see that the temperature and humidity horizontally is same, not vertically. Vertically it will change, but horizontally it will have the same temperature and humidity. So it happens when the air stays stagnant over a surface for a long time. If it is a cold region, if there is snowfall, flat region snowfall, so it would become a cold air mass. Good question. Okay. What makes it rain, sir? What makes it rain? Uh, if the air is lifted upwards, if any reason the air moves upwards, the temperature will fall down, it would start condensation, and when condensation would start, it forms clouds, and further it rises. When it rises, it reaches the saturation point, the maximum it can carry, and then after that, if it rises or the temperature falls, it would start raining. Great. See, this is how a class should be. Lots of questions from your end, and I should be challenged every time. And I would love to say, oh, I really don't know. I'll check it out and come get back to you tomorrow. That's something I would love to say to my kids. So that level of questions is what I expect from you guys. Okay. So moving ahead, we have finished this slide. Okay. And there is one more type of cloud that we missed to discuss. That type of cloud is called as cumulonimbus clouds. Cumulonimbus. Imagine a land becomes very, very hot due to some reason, and there is very high movement of air upwards, very fast and in huge quantity. So there would be clouds that are formed and which takes an anvil shape. Anvil means something like the cobbler puts his shoes into when he works, right? You have seen a shoemaker, there would be a stand like this and he puts the shoe inside. Yeah, yeah. So that is called as an anvil shape. So when the air rises all together suddenly in one go, it forms a cumulonimbus clouds. These clouds extend from the surface up to 10 to 12 kilometers of height. Okay, and when they cause rainfall, they cause heavy rainfall, and these are the clouds that causes hailstones. You would have seen, have you guys seen hailstones? Yes, in Maharashtra? Nice, lucky. Yeah, sometimes it happens. So what does happen? Uh, Water drop condense, it tries to come down, but air is rising upward, so it is again pushed upward. When it goes up, a second layer is covered. It tries to come down, again pushed upward. Third layer is covered, fourth layer, fifth layer, and become a big until it gravity pulls it down. It comes as a stone. So we call it. What do you call it in Marathi? Huh? Gara. Okay. What do you call hailstones in Delhi? Ole. Right? What do you call in Assam? Hailstones falling? Okay. In Kerala, we call it Ali. I don't know the specific name. No problem. In Kerala, we call it Aliparam. Aliparam. Yeah. Okay. So hailstones are also covered. So such types of clouds are called as cumulonimbus clouds. And usually when we hear about cloud bursts and all, these are the clouds that cause cloud bursts. Oh yeah. Yeah. Well, cumulonimbus clouds would be formed over deserts. Uh, Very less because the moisture is less in the air atmosphere there. There is no moisture. Even if it clouds, it is not capable to be such a big cloud. It can, surely can. I recently heard a news today. There was a first time snowfall that happened in the desert in Saudi Arabia. Yeah. Okay. So anything can happen in geography. Great. Shall we move ahead, guys?
Yes, sir.
Cyclones. Yeah, now we come to the topic of cyclones. Okay. Now, can you guys tell me which is the area in India that is most affected by cyclones every year?
Kerala.
Kerala is not much affected.
So, Odisha.
Very good. Odisha, Andhra Pradesh. Tamil Nadu, these are the eastern coast. These are the areas that get affected every year due to cyclones, and millions of people are translocate or moved from their places to safer zones, higher zones, and it's a very big loss of life and property every year. And can you guys remember which month do you see these cyclones? It doesn't happen year long. If you had paid attention, you could have seen which months can you see cyclones? April. No, not April, not July, August. Then right now we have a cyclone. Right now, October, November, these are the time where you usually, it's not again, but it's usually. So why? We'll understand. So cyclones. Cyclones are whirling movement of air that creates lot of rainfall, right? So cyclones can be divided into two major types. Tropical cyclones that India sees. Tropical cyclone. Okay? Tropical cyclones. We can see them between 10° to 30° latitudes, both north and southern hemisphere, 10 to 30° latitudes. Okay. Then the second type of cyclones are temperate cyclones. The second type of cyclones are temperate cyclones. We see them around 60° latitudes. Temperate cyclones, we see them around 60° latitudes. All okay? Done? Now, temperate cyclones. So now let's forget about temperate cyclones. We'll come to them. Both of them have different formation reasons and different reasons why they are formed. So now we are going to tropical cyclones. Okay? Tropical cyclones, we also call them as thermal induced cyclones because they are created due to heating. So that's why we call them as thermal induced cyclones. Thermal induced cyclones. Done? Now let me tell you the story. So before understanding why, where, we'll have a short story in detail. The structure and all we'll study when we do the detail. Okay, India, Bay of Bengal, Arabian Sea. Now you guys tell me during summers, so April, May, which would get heated up faster? The land will get heated faster or the water will get heated up faster? Huh? Uh, the offline friend is saying land. What's your name? Pratigna. Nice name. Pratigna is saying land will get heated up very fast during summer. Online friends, what do you agree with this statement or not? Come on, say yes or no.
Yes, sir. Think
Okay,
so. I think.
very good. Why? The specific heat of land is less, while the specific heat of water is more. Water takes more time to get heated up and it takes more time to cool also. The example you would have felt evening around 4 o'clock when you enter the swimming pool, the water would still be warmer. Yes or no? At the beaches also, yeah, very true. So water takes a time. So during the summer season, during the April, May, the land will get heated, hot, whereas the water will remain cold. Clear? So there would be low pressure. When it is heated, air will rise and low pressure would be created over the land. April, May, June, July, the summer season gets over. August, September, now we are entering into the winter season, right? The colder season. Now what will happen? Which will become colder fast? Land will become colder fast. So land has become cold now, but the water is still hot. Okay? The water is still hot. Now what will happen? When it is hot, the air will get heated up. Yes or no? And if at this condition the water can reach a temperature of 26.5 degrees Celsius or more than that, it creates a low pressure, air would rise upwards, and from the adjoining areas, air will be pulled into this low pressure. I'll explain again. I'm zooming it out here. So if the water temperature reaches 26.5 degrees Celsius, it will get heated up and the air above it would start rising. Air rised upwards, it would, what pressure would it create here? The air has gone, so it would create low pressure. And when you see a low pressure, surrounding high pressures, wind would start blowing into this low. Where the temperature is maximum and where the pressure is the lowest. So it would be a range. For example, here the pressure would be 1000, here it would be 1010, here it would be 1020, 1030. So it would be a range. So where the temperature is maximum and the pressure is the lowest, that would be the center point of the cycle. There is the core of the cycle. Good question. Okay. So now the temperature is 26, minimum temperature required is this much for the cyclone to form. If the temperature is 25 and all, there would be no cyclone formation. So the minimum temperature required in the sea for formation of cyclones is how much? 26.5 degrees Celsius. Some books it's written 27. Okay. So now what happens? 26 degrees Celsius, it will heat the air and the air will start rising upwards, creating a low pressure. So when there is no air here, air will start to blow in from all directions into this point. And due to the Coriolis force, this air would start rotating in the anti-clockwise in the northern hemisphere. It would start spinning anti-clockwise in the northern hemisphere. Okay? Okay. Now what happens? When the air starts rising up, it will also take water vapor from the oceans, right? So why cyclones are formed only in the oceans? Because here uh, the water molecules will become water vapor and it will trap some heat from the surrounding into it. So a water molecule from the ocean will become a water vapor and it will trap heat. This is called as the latent heat of evaporation. Latent heat of evaporation. Now, this air will rise It will cool down, forming clouds, and from water vapor, it will get converted into water droplets again, and it will lose the heat there. It is called as latent heat of condensation. This is what gives power to the entire system to rotate. And the winds that are flowing, the primary winds that we study, the trade winds, they will push these cyclones in the direction they are flowing, and they enter the land. We call it landfall. Now, when it has entered the land, the supply of water has been cut. No latent heat of condensation, no latent heat of evaporation. The cyclone will start getting weaker, and within 3 to 4 days, the cyclone will. But before that, it creates a lot of havoc, winds, rainfall, heavy rainfall, causing floods. So, tropical cyclones, clear, my dear friends? Online friends, all okay? Any question? Any question? So, the brother said Kerala? Why not in Kerala? Why only in the North Bay of Bengal? Anybody can answer this question for me? It's a very interesting question. It has been asked in UPSC prelims at least 3 times. So why this can happen in the Arabian Sea also, and there are cyclones that form in the Arabian Sea also, but mostly they form in the Bay of Bengal. Why? Yes, online friends, come on. I need answers. No problem if you make mistakes. Okay, so uh, okay, why the pressure isn't low enough? So pressure isn't low means you're saying that the temperature of 26.5 is not easily achievable here, right? Why? Because Arabian Sea, you can see Pakistan, then you have Saudi Arabia. It goes like this. So the bottom part is open, more open. Arabian Sea is comparatively more open. So there is mixing of water which allows 26.5 degrees to reach rarely. But when it comes to Bay of Bengal, you have Bangladesh, then you have Myanmar, you have Thailand, Malaysia. So almost it is covered. It is a more enclosed water body. So as it is more enclosed, there is less mixing and there is more chance of temperature reaching 27 degrees Celsius. Is that clear, everybody? Okay. Now, that's not the only reason. Another reason is we have the Western Ghats here, which is a very continuous chain of mountain. Even if the cyclone enters, these mountains will block it. But when it comes to the Eastern Ghats, they are pieces. Sechachalam Hills, they are small pieces. So more gaps and they can enter easily. So these are the reasons why the eastern coast of India has more cyclones than the western coast. So guys, geography is not boring subject, right? What do you guys feel? Is it interesting or boring? Yeah, it's interesting if you can understand the concept. And if you try to by heart geography, it's impossible. You would get stuck. Okay. Cyclones in Japan. Yes, they have tropical cyclones there. They call them typhoons. Okay. In Indian Ocean region, they are called cyclones. Okay. So shall we move ahead? So we have understood tropical cyclones. We said the ocean, warm oceans is necessary. Write down 26.5 degrees Celsius, which creates a low pressure. Okay. And the center where the temperature is highest and the pressure is lowest, this area is called as the eye of the cyclone. This region is called as the eye of the cyclone. Okay, now there's a very interesting thing. The eye region, I told you it's a low pressure region. Pressure would be the lowest and the temperature would be the highest. So the wind coming in from all regions will come and start moving up like this. So if I catch Palak and make Palak stand here in the eye, Palak will never experience a single drop of rainfall. The sky would be clear over the eye and the air rises upwards like this. And here there would be heavy rainfall, but in the eye, there would be no rainfall. It would be clear sky. And when the cyclone is moving in this direction, if Palak is capable of running in that direction with the eye, she'll never get wet. So this center region is called as the eye of the cyclone and the other regions are called as the surrounding areas. So size of cyclones, how long they last, all of these we'll do when we study these topics in detail. Okay, shall we move ahead, friends? So spiral pattern, we know that the spiral pattern happens. Why does the spiral pattern happens?
Due to the Coriolis force.
Very, very good. And you guys tell me the Coriolis deflection in the northern hemisphere is in which direction?
Right hand side.
To the right, right? To the right in the northern hemisphere. And to the, yeah, the Coriolis force differs in the northern and southern hemisphere. Any moving object will get deflected to its right in the northern hemisphere, and any moving object will get deflected to its left in the southern hemisphere due to the shape of the earth. So now, guys, just a second. Air is moving in from everybody. We are seeing the top view. Okay? Air is moving from everywhere. Now, what will happen in the northern hemisphere? The deflection would be towards the right. So, the cyclones rotate in an anti-clockwise direction in the northern hemisphere. In the southern hemisphere, deflection to the left. So, only if you remember this, you can make it out. So, the clock rotation would be clockwise in the southern hemisphere. All okay? The examples: Amphan, Cyclone, Biparjoy. So remember the recent cyclones that have affected the world in the last 1 year of your preparation. You can quote them as examples here also. In also disaster management, you can write down there. Okay. Now, the second type of cyclones are temperate cyclones. Okay. So we said tropical cyclones are thermally induced cyclones because they are caused due to heating. You saw that water is heated. Temperate cyclones are not directly caused due to heating. And to understand how temperate cyclone is formed, we have to study air masses, fronts, types of fronts in detail, and then only you can understand properly how temperate cyclones are formed. Okay? But as we are going in an overview, I'll explain it in short. Try to keep there, and if more questions, we'll add it on. Okay, so see, temperate cyclones. So temperate cyclones, I said, are usually formed around the 60-degree latitudes. Around 60-degree latitudes. Remember, we studied frontal rainfall. We studied frontal rainfall in the last topic, types of precipitation. Very good. So same way, the same thing. The cold air mass from here comes and the warm air mass from here comes and they meet together around 60-degree. So when some two different things meet, that is what we call it as a front, right? The India-Pakistan front, the war front, that's the word. So now what happens? Just a second, please pay attention. So when the air masses come and meet, okay, why and all we'll study when we enter into detail. It would another take 50 or 20 minutes to explain that part. So when the warm air mass and the cold air mass come and meet at some condition, see guys, they start rotating like this. So this is the warm air mass and this is the cold front. The warm front would be rotating and the cold one will try to follow it, and this entire system will start rotating like this. This type of cyclones are called as temperate. Why do they rotate? How do they rotate? I said to explain all this, I would have to first explain air masses to you. I would have to explain fronts to you. And then only just remember, when the air masses come and meet around 60-degree, they start rotating. Huh? Uh, Very good. We studied tropical cyclones. They can form only over the oceans. These cyclones can form over the land and oceans anywhere around 60 degrees, the entire belt they can form. Good question. So air would come, meet, and they'll start rotating like this. Okay. For now, understand this much. Warm air mass, cold air mass, they come and meet, and then they start rotating like this. Such type of cyclones are called as temperate cyclones. They are formed at the polar front between 35 to 60-degree latitudes. They are formed between 35 to 60 degrees, and they can be hundreds of times bigger than tropical cyclones in size, in the area they affect. Okay. Then they cause sudden weather changes, western disturbances in northern India. So when these air masses come and they start rotating, you can see sudden changes. For example, the temperature suddenly decreases, then you have rainfall, then suddenly temperature rises slowly. So you can see sudden changes in temperature in case of temperate cyclones. Then differences, tropical cyclone, they have a warm core and system symmetric, the shape is symmetric. Temperate cyclone, they are cold plus warm fronts meeting together and they are asymmetric. And they are asymmetric. Okay. Okay. So tropical cyclones and temperate cyclones. And one thing we studied the major difference, temperate cyclones can be formed over the land masses also. And that is why they bring rainfall even to the continental interior of Siberia, the entire Russia. You have Siberia, right? The central part. Even it gets rainfall due to temperate. Okay, any questions, guys? I think there would be a lot of questions. I expect at least 3, 4 questions before I move ahead.
Yes, sir.
Go.
So first thing, like we observe these temperate cyclones over the 35 to 60 degree latitude.
Latitudes.
Because there's a meeting of wind
Cold
at the
air
low
mass
pressure.
and warm air mass. We say air
Yes.
mass. Go ahead.
Okay. The meeting of the warm and cold air mass at the 60-degree low pressure zone.
Belt.
But we also have the similar low pressure zone at the equator at the 0-degree mark.
Right.
Why don't we observe these things over there?
You're talking about cyclones?
Yes, exactly.
Very, very beautiful question. What's your name?
Siddhant.
Huh?
Siddhant.
Siddhant. Lovely. So, one reason why you don't see tropical cyclones or temperate cyclones in 0 degree is that the Coriolis force is absent in the equator. The Coriolis force is 0 at the equator. Why? So, that's a law. The Coriolis force is 0 at the equator and it increases as we move from the equator towards the poles. And this is due to the shape of the earth. So, Coriolis force is minimum or 0 near the equator and it is maximum at the poles. So, if there is no Coriolis force, there can be no rotational movement, and that is one reason why cyclones are absent near the equator. Okay, Siddhant, all okay?
Yes, sir. Yes, sir.
The,
Got it. So just one more thing.
just a
Like
second,
for the
just a second. Okay, yeah, Siddharth, go ahead.
yeah, so like for the tropical cyclones, we studied that it happens when the temperature is over 26 degrees,
Very true.
and the same thing cannot be achieved in the Arabian Sea.
The same thing
Because
cannot be. No, no, no. It is comparatively rarely achieved in the.
yeah,
Yeah, there are cyclones in the
uh,
Arabian Sea.
okay. So like in general, like what is the so like it is restricted by the temperature
Yeah,
that cyclones will happen that
yeah,
frequently in the Arabian Sea.
very
But
true.
like, what is the temperature that is usually there? Because there's a desert above it and the Arctic zone below. So there might be places where the conditions might be.
Yeah, there are cyclones that form in the Arabian Sea also. But as I said, take out the map, check out the Arabian Sea. The bottom part is completely open, and whereas the Bay of Bengal is comparatively more closed. So when the it is closed, the water mixing with other parts would be reduced. So it can maintain the temperature from it gets heated and it can maintain the temperature. Arabian Sea is more open, so it is more rarely that the temperature is reaching 26.5 degrees Celsius. So it has lesser cyclones.
Okay, so like maintaining the temperature for a period is also required.
Yeah, it means uh, what we say is that only if the temperature of a particular place above the ocean reaches 26.5 degrees Celsius, it creates enough low pressure for air to rise and this system to get maintained as one unit. So that is the minimum temperature required for cyclones to form. So if the temperature is 28, a more powerful cyclone would form.
Okay, okay. So usually in that day it is less than that.
Usually, yeah, very good, nice.
Okay, so
And
thank you.
anybody else? Any other question? Yeah. There might be lot of cyclones at the polar region. That's a very good question. That's a very good question. But yeah, the problem is when you need to have cyclones, you have air rising upwards. And in poles, we have a high pressure where air is continuously descending, creating the polar high pressure belt. Good question again. So the question was, as the Coriolis force is maximum in the poles, there should be more cyclones. That was a question. But I said, as the air is continuously descending over the poles, creating the polar high pressure belt, cyclones are not formed. Nice. Now this class is more interesting. This is where questions make the class interesting. Okay, online friends, any other question? Christina Chaco, Palak, Rimin. I can only see 4 of your names. All okay, my dear friends? Christina, please, please don't message, my dear friend. I would love to hear you also. So please speak up. Okay. So moving ahead. Cyclones. We just studied cyclones, right? Which country is this? Huh? Which country is this? USA. Very good. Okay, the country that is creating all the problems. So if it is a cyclone, center would be a low pressure, right? And in, USA is in the northern hemisphere or the southern hemisphere? Northern hemisphere. Very good. So the winds are moving in a cyclone in the anti-clockwise direction. And the opposite of cyclone is an anti-cyclone, where the center is the high pressure. Okay, the reverse condition. So we studied about cyclone, everything opposite would be anticyclone. So center would be high pressure on the ground and air will start flowing from this high pressure outwards on the ground and the air will start descending from above into this high reverse. So anticyclone will move clockwise direction in the northern. Cyclones anti-clockwise. So just if you remember Farrell's law, deflection to the right in the northern hemisphere. That's the thing. Then you can derive all these directions. Live in the vida loca. And always I would say preparation is a long, long journey. So you should always keep your morale high. You should be fighting and it's not a small battle, right? It's a 1.5 years long battle. So always try to keep yourself charged. Okay. Anticyclones can happen. Yes, it can happen anywhere except the equatorial belt. Okay. Good. Shall we move ahead? El Nino, La Nina, and Enzo. Again, a very, very big topic in itself. I'll explain you the basics here. Okay. Again, when we study climatology, we'll do these topics in detail. So as this course is for quick revision, we are doing it very fast. So write down the heading: El Nino, La Nina, and Enso. Okay. So take out your maps. You can, if you are familiar with the maps, then it's great. If you're not, please take out the world map. Which continent does this look like? Huh? Which continent does this look like? Doesn't look like any continent. It is South America. Okay? The west side of South America. Right? Guys, all okay? Shall I move ahead? Okay. And here, which is this? Australia. Very good. This is Australia. So, which ocean is this? Huh? Pacific Ocean. Very, very, very good. Online friends, all okay with this? Australia, South America, and Pacific Ocean. Have you found out the locations? Yes or no?
Yes, sir.
Great. Now, when we study oceanography, that's the next topic, we'll study about ocean currents. But here I have to give you two ocean currents. I have to name two ocean currents. One is the West Australian, East Australian current, which is a warm current. Ocean currents, to explain it very quickly, have you seen that movie Finding Nemo? Yeah, in that the turtle jumps into an ocean currents and move very fast with the turtles. Have you seen that? So ocean currents are like rivers flowing inside oceans faster. Okay. So Australia, we have the East Australian current, which is a cold current, and the equator almost is like this. So, East Australian current is a warm current. Clear, everybody? Now, there is a cold current flowing here on the west coast of South America. We call it the Peru current or the Chile current, and that is a cold current. I'm expecting too much from you because we are not going in detail right now. Try to get the concepts and then it would be easy to add to it. Okay? Can you hear me? Online friends? So, Australia, we have the warm current, and South America, we have the cold current. Clear? Now, you guys tell me, if a warm current is flowing from this area, it will heat the nearby water? Yes or no? So what will happen if the water gets heated? Air will rise. Very good. Air will start rising upwards, creating what pressure? Low pressure. And here it's a cold current. Temperature of the water is going down. So it will create a high pressure. High pressure and low pressure. Right? So now winds will start blowing from the surface, from this high pressure to this low pressure. Okay. Now I'm going to show this diagram here again, but in a different angle for you to understand. This is Australia and this is South America and this is the ocean level water. Okay. Please, eyes on the board for 2 minutes. So we have a warm current here and we have a cold current here, right? Now we are looking at the horizontal view. This was the top view, horizontal view. Warm, cold current. Now, what pressure would be created near Australia? Online friends, wake up. Low pressure. What pressure would be created near South America? High pressure. Now, here high pressure is created. Here low pressure is created. Now wind will blow along the surface from the high pressure to the low pressure. Yes or no? Yes. And here there is low pressure. So what will happen? Wind will start rising upwards. It will form clouds and it will give rainfall to Australia. And this cycle would come back, and here it is high pressure, so wind will come downwards. So this is the normal cycle that happens in the Pacific Ocean. If you are clear with the normal cycle, then only we can go to El Nino and La Nina. Everybody, are you clear with this normal cycle? Online friends, I want a yes from everybody or no from everybody.
Yes, sir.
Okay. Yes. Okay. Great. So this is the normal condition. I am repeating again. South America, Australia. Australia, we have the warm East Australian current which creates a low pressure. We have a cold current here which creates a high pressure. Wind will start blowing above the surface of the water from the high pressure to the low pressure. Yes or no? And from this low pressure, wind will start rising upwards and that will form a cycle like this. This is called as the normal condition. So in normal condition, where which area would get rainfall? Australia, because air is rising up, cloud formation, rainfall will happen in Australia. South America, no rainfall. All okay? Very good. Now this is the first condition. We are going to call it as the normal condition. It's called as the normal condition. Now, we will go to the first condition, La Nina. Okay? La Nina. Everybody understood normal condition, yes or no? Very good. Now, if the normal condition becomes more powerful, high pressure, powerful high pressure, low pressure, powerful low pressure, wind faster, rainfall more in Australia, dry in South America. So if this condition is made more powerful, that is called as La Nina. So La Nina is original condition more powerful. Okay. Original condition, when it becomes more powerful, we call it La Nina. Palak, all okay? Please, please don't type, my dear friends. Because you know, when I am the only one speaking, it's kind of boring. If you're with your friends and only one person is speaking and another person is like, hmm, that gets really boring, right? Yeah. So we don't want that. Okay. So La Lina, all of you understood? La Lina is normal condition, more powerful. Where would be rainfall? Australia. Lovely. Now I'm going to draw El Nino. Why would it get powerful? Due to many reasons we don't understand. So we as geographer, we don't want to say we don't understand. So we say climate change. Okay. So we remain very confident. We say climate change due to climate change. Okay. Now the same conditions. Australia, South America, the river water, ocean water. Now, due to climate change and due to unknown circumstances, sometimes the warm current is replaced by a cold current in East Australian coast. Before normal condition, it was warm current, right? So now the warm current is replaced by a cold current. And here you have a comparatively warm current. Okay? It is reversed. We don't know the reason. And warm cold is like the comparative temperature, the temperature of this compared to the temperature of this. That's how we call it warm and cold. Okay. So now when this condition happens, the cold current is near Australian east coast, warm in the west coast of South America, right? Now you guys tell me, where would be the low pressure created? South America, we have the low pressure created. Where would be the high pressure? High Australia. Wind will start moving from high pressure to low pressure. That won't change. Air will start rising upwards here. Cloud formation. Rainfall in South America. Australia, no cloud formation. Wind is coming down. Dry in Australia. This condition is called as El Nino. This condition is called as El Nino. Uh, we don't compare it like this. So, cold current, yeah, there would be cold currents in Antarctica. But cold and warm currents are usually easily explained that currents that are carrying water from the equator to the poles, warm water from the equator to the poles are warm current. And current carrying cold water from the poles to the equator, we call it cold current. Okay. So it just carries water from one place to a length to balance. So that's how currents are formed. So now if the condition is reversed, there would be a lot of rainfall in South America, but no rainfall in Australia. Okay. Now why we are linking this to India also? If it is normal condition, India will have normal rainfall. If the normal conditions becomes powerful, what do we call that? La Nina. Very good. So India will get above average rainfall. In case of La Nina, India will get above average rainfall. So more rainfall. India will get more rainfall. All okay? Now, when the El Nino condition arrives, India would be facing a drought year. There would be very less rainfall compared to the average, and it would be a drought year in India. You know, 65% of our population is dependent on agriculture, and out of our farming land, 70% of the farming land are directly dependent on rainfall. There is no other source of irrigation. So that year we would have a bad harvest. This is the basic and simple, a short version of El Nino and La Nina. So a lot of things to add, we'll add it when we do it in detail. El Nino and La. All okay? Shall I move ahead? Online friends, I think there should be at least 10 questions from this area. Any questions? Yeah, why is India affected? So, this cycle of air circulation is called as Walker cell. Okay, so can you see in this map, this is South America, this is Australia, and here we have India. Can you see this? So there is one cycle Walker cell going on like this, and there is a connected Walker cell that goes like this, and it goes continuously throughout the. So when one cycle is disturbed, it disturbs the other also. Very good question. Any other questions? Come on, friends. Any other questions? No questions. Okay. So Enzo, we'll understand this word also. This is called as El Nino Southern Oscillation. El Nino Southern Oscillation. It's kind of very simple, guys. I have told you the story of the air circulation, right? Yes or no? Just a second. Eyes on the board. So we've told you about the air circulation, right? So the air circulation will also cause a movement of in the water also. There is also movement in the water. When I talk about water, the first case, normal condition, and the powerful case, La Nina, right? Where is the high pressure? Come on, fast. Where is the high pressure? South America. Very good. And where is the low pressure? Australia. Now winds will blow along the ocean surface from the high surface to the low pressure. So what will happen? It will push the water from this area and the water will get accumulated like this. The wind will also push the water here. Okay. Now when the wind pushes the water from here, cold water will rise to replace this water, bringing nutrients, and it will create a good fishing season in the Peru coast. Okay. Now El Nino condition, Australia, South America. Opposite condition, where will be the high pressure? Australia. Very good. And where would be the low pressure? Now the wind would blow from here to here, right? So the water will be pushed and it would get accumulated like this. It would get accumulated near South America. So there is no rising of cold water, less nutrients, and the fishing season will also be destroyed. So this is the movement of water. Now, if you study the movement of air and the movement of water together, we call it ENSO, El Nino Southern Oscillation. El Nino Southern Oscillation. El Nino Southern Oscillation. So, write down these points first. You understood the concept? Siddhant, Rimin, Palak?
Yes, sir.
Yeah, I think Siddhant has one question. Go ahead, Siddhant.
Not a question, sir.
Hmm?
But can you explain this one more time, please?
Sure.
How does the water part come into picture? El Nino and La Nina?
Okay. So now I'll explain it once more. I'll explain the both the parts together. Okay. So normal conditions. Australia, South America. Normal condition and La Nina. We are talking about this. Warm current in Australia, low pressure, high pressure here. So wind will always, this is the ocean surface. Wind will always move from high pressure to the low pressure. And when the wind flows in this direction, it will push the water and the water will get accumulated in the coast of Australia. So when the upper layer water is removed, To replace that water, cold water will start rising from the bottom, bringing in nutrients, causing a good fishing season in South America. Now, opposite. South America. Here we have the high pressure is created where? In Australia, right? And low pressure is created in South America. So the wind will blow from high to low and it will accumulate water in the coast of South America. So no rising of water, we call it upwelling. We don't say rising of water, we say upwelling of water is stopped. Bad fishing season for South America. Is that clear, my dear friend? And if you are not, please ask me, I can repeat it again.
Yes, sir, it's clear. Thank you.
Very good. Rimin, Palak.
Yes, sir.
Great.
Then will Australia have a good fishing when Australia has a high pressure, sir?
When what do you say? When Australia normal condition, the fishing would be great in the Peru coast. Whether this is changed with the, I really don't know whether there's a good fishing. There might be fishing, but Peru coast, they are completely dependent on fishing. Fishing is one of the major occupations in Chile and all. So that's why it's more important there. Australia, the eastern coast, we have the coral reefs and also anyhow there would be less fishing, less movement of vehicles. Great Barrier Reef.
Okay, sir, thank you.
No problem. Very good question. This shows that you understood the concept. Very good. Christina, any question from your end, my dear friend? So write down El Nino, warming of the Pacific Ocean near Peru, the opposite condition. So write down warming of the Pacific Ocean near Peru. And what will happen? A weak monsoon in India. A weak monsoon in India. Then La Nina, cooling of the Pacific Ocean near Peru. Cooling of the Pacific Ocean near Peru. We have stronger monsoon. We have stronger monsoon. Then Enzo is El Nino, the movement in the air, plus southern oscillation, the movement in the water. Okay. Now, something to remember, El Nino, El, evil for Indian monsoon, El Nino. So you can remember. So when it's El Nino, Indian monsoons are affected by. That's it. So we'll take a 10 minutes break. Okay, so in this 5-10 minutes, did you guys come up with any interesting questions? No? Online friends?
Also, not a question, but so when the during La Nina, let's say, the low pressure that is there in the Australian Sea causes wind, and the water moves down the system during that time.
The La Nina is the normal condition, just exaggerated. So the low.
Yes, yes, yes.
So the
And
low.
the water that is around the Australian eastern side.
Yeah.
And on the southern South American side, it will rise. Like the water level will increase.
No. Normal condition, here we have the high pressure, here we have the low pressure. winds will flow in this direction, so water will be pushed from here and it will accumulate more in the Australian region, right? The normal condition, water accumulates here.
Okay.
So La Nina, more water would accumulate here, more powerful high pressure and low pressure.
Okay, so then what was upwelling of water? Where does that happen?
So when here in normal conditions and La Nina, when water is pushed, so the upper layer of water would be pushed off. So to replace that water on the Peru coast, water from below will upwell with nutrients coming to the top, and this will help fishing season, improve the fishing season.
Okay, sir. Yes, now got it. Now got it.
Good. I also had this confusion for a very long time when I was preparing, and then at last it got clear. So no problem. All okay? Shall we move ahead? Yeah. Climate classification. Now, again, this is a topic alone that would take 3 hours to discuss. But now we just have to understand climate classifications. I'll give you a brief idea. So, there are different types of climates that you will study. By naming them, you can see, for example, 0 to 10 degree, this entire latitude, you can see equatorial type of climate, right? Recently, I visited Malaysia, so there I saw equatorial rainforest. Morning it would be hot, and evening usually there would be rainfall. So this entire belt is equatorial type of climate. Second, uh, please don't note down all these. Means in the sense you can, but this is not. We have to go into detail and jump into detail. This is just an overview. Now, from 10 to 30 degrees on the eastern side of the continents, you have deciduous type of climate. Okay, and in between 10 to 30 degree on the western side, you have deserts, hot desert, tropical deserts. And in between in this region, you have savanna type of climate. How, why, where, we'll be studying everything, don't worry. And from 30 to 60-degree latitude, you have European type of climate. And here you have China type of climate. And in between, you have cold deserts. Then from 60 to 70, yeah, 70, yeah, you have Manchurian type of climate here. Okay, sorry, European type of climate is here. You have Mediterranean type of climate here. And in between, you have steppe type of climate. And then you have taiga and you have tundra. So these are all the climate classification, different types of climate that we classify in geography. And when we study climate, we have to study every climate in detail. For example, equatorial tropical climate, how much rainfall it is getting, how is the sunlight, what kind of vegetation is there. Then you will study savanna, or then you will study savanna type of climate, desert type of climate. All these climates we will study in detail, okay, one by one. Now, what is climate classification? Kopin, a German climatologist, he made a chart like this, okay, and he said, if you place this chart over any continent, you will get an approximate idea of that, what kind of climate would be there. For example, if there is a continent like this is equator, right? So in this area, I place this chart. Okay, here it would be tropical. 10 to 30 degree western side would always be tropical deserts. So he made a clue chart for climate. So if you can take this chart and place above any continent, you can find the approximate climate. Geography can never be cut and right like chemistry or physics. So you can find the approximate type of climate in that place. Yeah, same goes means you have to flip it like this. So it would go in the southern hemisphere also. Now, Köppen used main conditions of temperature, rainfall, and vegetation. Just write down Köppen's classification. He used the criteria like temperature, rainfall, and vegetation to classify the world into different climatic zones. To classify the world into different climatic zones. Okay? And he gave letters representing different temperatures. For example, when he talk about temperature, he used the letters from A, B, C, D, and E. So A was tropical, hot. B he used for deserts. C subtropical. D temperate. And E frost, cold. Don't worry, I'm just giving you an overall idea. We'll do this in detail. So he gave different letters to represent different temperatures. A, capital A, B, C, D, and E. So that's what is written here. Capital A means tropical. Then the second letter shows what kind of rainfall is there. Understood? So W, he used this word to show, small w showed that is rainfall is throughout the year, continuous rainfall throughout the year. S, small s, dry summer, wet winter. Small w, dry winter, wet summer. So he used letters like this. Don't worry, we are not going jumping into the letters right now. And he classified the entire world climate into different zones. And he gave us a cheat sheet. So this cheat sheet, I take it and put it in front of the any continent with the equator line matching. We can understand the climatic regions of that place. Okay. F is rainfall throughout the year. Sorry, not W. F, small f is showing rainfall would be throughout the year. So this region, equatorial region, A means tropical, hot. The temperature would be A, and small f, which would describe that there is rainfall throughout the year. Okay, done. So you can just write down Köppen's classification. It was based on temperature, rainfall, and vegetation. And also then he added another factor called height. According to height also the climate changes. When you start moving a mountain, you can understand that. Okay, very good. Then examples like AW, tropical savanna. CW, C stands for subtropical regions. And W, dry winters. Okay, done? Okay, so you will study Köppen's classification in detail. Usually, Köppen's classification is taught for geography optional, but I prefer teaching it in an easy way to general study students also, because you can remember the entire climatic regions in that way, and all the climatic regions you can connect with each other. And once you can understand the climatic region, you can also link the same to understanding the biomes of the region. You can link that style to understand the flora of the region. link the same pattern to understand fauna of the region. So that is why I do it to GS students also, a simpler version. Okay, so Köppen's classification is based on temperature and rainfall. Okay, there is another classification which is famous, is called as Thorne weight classification. Thorne weight classification. Another classification which is very famous. The major difference is that Köppen's classification, he considered rainfall, but Thornwaite took it a step further. He considered evapotranspiration. He said only the rainfall should not be counted. How much water is getting evaporated, that also should be counted to understand how much water is accumulating there, right? So he went a further step ahead and used the term evapotranspiration, which is more scientific, but it is used less in case of India. So Köppen's classification and Thornwaite classification, you can remember the name. I'll teach you Köppen's classification when we enter into the detailed study syllabus. Now just understand these are the climate classifications. Okay. Done? Shall we move ahead? So these are how the climate region was classified. So see, the equatorial belt, it would pass somewhere like this. So this area is tropical type of climate. Then you have dry deserts on the western coast of continents. Temperate. Before that you have subtropical, then you have temperate, and then you have polar type of climate. So they have classified into the world. And when you understand this climate classification, it would be a base to answer lot of questions. For example, they tell you to explain the pattern of world precipitation. You can use this pattern. So that's like a core answer that we should not miss. And once you understand that, at least 10 to 12 topics you can use the same pattern and answer the question. So we'll do Köppen's classification in detail. Okay, so what we did in climatology, a one-page summary, we studied atmosphere. We studied 5 layers of the atmosphere. Can you guys name the 5 layers? Come on. What's your name? Suresh. Nice. 5 layers, guys. Online friends and offline friends. 5 layers. Name fast. Troposphere, stratosphere. Come on, online friends. Troposphere, stratosphere, mesosphere, thermosphere, and exosphere. Very good. Then we studied ozone layer, which lies in the stratosphere. So insolation, it affects temperature distribution. We understood how different areas of the earth get different types of sunlight, and that is why the temperature there are different. And we studied albedo. What is the meaning of albedo, my dear friends? No problem. I'm not testing you. I'm just trying to get you motivated. Albedo. And then albedo, what do you understand by albedo, friends? Albedo means the capacity of a surface to reflect sunlight. If a surface is reflecting entire sunlight, we say the albedo is 100. Okay. So where it applies to geography, areas where you have snow will reflect almost 90% of the sunlight. That's why snow does not melt. But in case of rainforest, the albedo is only 15% is reflected. Rest everything is captured. That is albedo. Then we studied pressure belts, right? We studied pressure belts. Remember, equatorial low pressure belt, subtropical high pressure belt, subpolar low pressure belt, and polar high pressure belt. Then we studied winds also, right? Winds, we studied primary winds, secondary winds, and local winds. Primary winds, we studied trade winds, westerlies, and polar easterlies. Secondary winds are monsoons, cyclones, and local winds we studied Chinook, Fohin, we studied some winds. Okay. Then today we studied El Nino Southern Oscillation, and jet streams also we talked about bands of air that move above the earth's surface, covering them like a garland, jet streams. Rainfall types we studied convectional rainfall, orographic, cyclonic, and one more, frontal. Very, very good. Then we studied tropical cyclones versus temperate cyclones, right? And at last, Köppen classification. Great. So we have finished the second slide. Now I have to change the slide. So prelims and master, we are going to the next presentation, oceanography. Okay, we'll take a 2 minutes break before that so that they can understand also. Okay, we have finished one, we are starting a new one. Any questions in the previous topics, guys, or any other topic? Now you can ask me. 2 minutes time for you guys. So any questions that you want? Anything. Can be about preparation, it can be about geography, or anywhere you're feeling tensed, lost. Any questions? How not to prepare? How not to prepare? First thing is, don't keep overthinking about people do. When I sit to study history, I'm thinking about, oh, geography is pending. So that is one major flaw that we do. All of us do. That's something that you should not do. And the first thing is to know your syllabus by heart. Only if you know your syllabus, you can guess which topics to read, which topics to omit. So general studies paper 1, paper 2, paper 3 and paper 4, the syllabus should be by heart. Unless and until you know the rules of the game, you cannot win the match. These are the two starting points, I would say. And when you are studying one subject, only have that book on your table. Keep rest of them very far away, where you can't even see them. So do that. That's one thing you can do. Okay. Any other question, guys? No? Okay. So,
When will
yeah.
this task completed, sir, and when will you start the original class?
That I think you have to ask the Alexa or the administration here, right? I can really not tell you an exact date, but they let me know. We'll start. Okay. Uh, so this would help you revise your NCRT, prepare yourself, right? So never wait for classes. That's another thing I can tell you. Classes are to motivate you, to give you a guidance, to just see that every day you're working. 90% of the effort is what you do after the class, how much you are preparing, right? If you have classes for the entire day with different best teachers from all over India, still you cannot clear unless you prepare yourself. I'm not saying classes would not be there, that would be there, that's a secondary part, but the primary part is your preparation. That is what is going to make or break this exam. Okay, guys. So, we studied the geomorphology. We studied the earth crust, right? Second, we studied climate or climatology. We studied the atmosphere. Now we are entering into the third realm, that is oceans. And once you understand that, the area where all these three, that is the biosphere, where life exists, where all of these three come and meet. So geography is a complete flow. Okay, so now let's move on to the ocean. Can you guys tell me which is the biggest ocean in the world? Pacific Ocean is the biggest ocean in the world. Very good. Now, do you remember studying a topic called as continental drift theory? Yes? Do you remember the big ocean, the one ocean that was formed first? Can you remember the name of that one ocean?
Panthalassa.
Panthalassa. Very good, right? And the remnant of Panthalassa today
Pacific Ocean.
is the Pacific Ocean, which is the remnant of Panthalassa. Very, very good. So, oceanography, exploring the blue planet. So, you guys would have surely come across a word. Yeah? Did you guys ever come across this word, Matsya 6000? No problem if you make mistakes. It's all about being confident. Yeah. It is part of the Samudrayan mission where India is developing a capsule where 3 people would be sent to a depth of 6,000 meters. Sea floor bedding, yeah. India had a now we had a mission in Europe, in a European vessel. We went to 5,000 meters. India is developing its own capsule called as Matsya 6000. Okay. Oceanography. And they say that we know more about the universe than we know about the ocean. That's so mysterious. Even you might find Aquaman somewhere one day. I don't push the possibility. It can be there, and there would be a country called as Atlantis somewhere. Maybe we have not seen it. Yeah, that's what we don't know about our ocean. So vast and so deep. We have scratched on the. We just have scratched it. Okay. So, what is oceanography? Oceanography is the sorry, scientific study of oceans, covering oceans. So, what all we study about the ocean? First, we study the ocean relief. What do you mean by relief? The move that we put when we have pain, right? Relief spray. What is relief, my dear friends? Relief is how is the structure of the land, whether there are mountains, whether there are plateaus, whether there are plains. Study about that structure is called as relief. So first we will study about the ocean relief. Okay. Second, temperature of the ocean. So how the ocean temperature varies as I move from the surface to the bottom. And another, how the ocean temperature varies if I move from the equator to the poles on the surface. Then we'll study salinity. What is salinity? Salt content in the ocean, salinity. So again, we'll study how the salinity will vary as we go down. Again, how the salinity will vary as we move from the equator to the poles. Currents, ocean currents. There are a lot of river-like water bodies flowing inside the ocean. So we'll study how they are created, where they are flowing, which are the main important currents, how do you name them. All these topics would come under currents. Tides. What are tides? This is tides. It looks like a Prabhudeva step. Okay. Tides. You would have seen sometimes when you go evening time to a beach, the beach is closed. They say you cannot enter high tide, right? So, due to the gravitational force of the moon, especially, and the sun, the water level rises and pulls back. We call them as tides. Then, marine resources. What are the resources that we get from marine area? So, these are all what we are going to study. Now, why are we studying? If we have an idea, we can better understand monsoons, how rainfall is created, how India is affected, what changes where can cause changes here, climate changes we can understand, fisheries and maritime boundaries, because we need maritime boundaries, right? Otherwise, what's the law? United Nations UN clause, United Nations laws of the sea. UNCLOS, UN clause. Yeah. So they have made a rule, United Nation. So like this is a country, up to 12 nautical mile would be the territorial water which would be owned by the country. Up to 200 mile, it is the special economic zone. Others can also pass by. And then you have the open oceans or the open waters to divide the sea according to the shape of the country. So that are the maritime boundaries. Okay. Okay. So, first, understanding the relief. Relief means how is the structure of the seashore. What do you guys think? Would there be lot of differences inside the sea? What are the factors that creates this different landforms on the surface? Can you guys tell me what are the processes that creates different landforms?
Also, the collision of the tectonic plates will be one.
Okay, very good.
Ridges and all.
Very good. Then you have studied agents of erosion, running water, wind, glaciers. Yes or no? They all create different landforms. Yes or no? But all these agents of erosion.
Human activity?
What is?
What about human activity?
Yeah, human activity. We see a big mountain, we keep a bomb and we make it a quarry. We take all the rocks and we make a depression. Like the Drishyam, he puts a car inside, right? In a quarry. So that would be a mountain. We have created a new landform there. True. Human activities can also be a reason. So all these agents of erosion are not very effective after the wind cannot affect the bottom part, right? Okay. So now we'll understand how the bottom of the ocean are. The first part is the continuation of the continent itself, and we call it the continental shelf. The average would be 0 to 200 meters. So we have the continental shelf. The slope would be less than 1 degree. So it would not be like this. Continental shelf would be slope would be very, very gentle. Okay. Now, what all we can say about the continental shelf? All the resources from the land which will be carried out by the wind would be deposited in the continental shelf. Yes or no? And the depth of the continental shelf will not be very high. It would be less than 200 meters. So sunlight will enter till the bottom, and that is why you can see lot of phytoplanktons, lot of what to say, fishes. So lot of fishes, and this would be the major fishing areas. And these are the region that had forest before, now had sunken. So you find oil, petroleum, natural gas. For example, Bombay High. So all these drilling happens in the continental shelf. It is also a source for gravel, sand that we can use for construction. So these are the important points about the continental. Okay, all okay. So let's first write down and then come back to the next part. So write down continental shelf. So the most important point you have to understand, it is the part of the continent even though it is submerged. So write down submerged part of the continent. Submerged part of the continent. Okay, examples, you know, the western coast of India is a coast of submergence. The coast has gone down, and that is why. So, see, it was like this, and now the coast has gone down like this. So now that is why you have deep ports, good ports in the western coast of India, because the coast has gone down and big vessels can come till here. Karwar, naval port, right? Very good. Okay. Maharashtra, Mumbai, again, very important port, right? Where are you from, my dear friend, Mahesh? Karnataka, oh, Karwar, your area, right? Yeah, one of the most beautiful regions of the world. The entire west coast of Karnataka. Where in Karnataka? Kolar. Oh, KGF. Nice. We have a Rocky Bhai here also with us. Okay. Yeah, always studies should go with a smile and a fun. That's how you keep your energy level. Okay. Okay. Continental shelf. You understood all about continental shelf, my dear friends? Again, the slope would be less. It is part of the continent. Sunlight will reach the bottom. And the area where sunlight reach, we call it photic zone. Photic. 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 Photons, light, right? Photic. Photic zones. And these are where you can find, for example, so this area would have been once upon a time forest, and it would be on the land. So and animals would have died and they would form petroleum and coal. Now they are submerged. So main petroleum refining or offshore rigs are found in the continental shelf. Okay, now when you keep going from this shelf, when you keep going from the shelf, at one point of time, suddenly the slope increases 2.5 to 3 degree. Suddenly the slope increases. And that is where we say the end of the continental shelf. And now begins the second part, continental slope. Continental slope. Now here in the continental slope, you can see that there would be no much deposition because it will flow down. Yes or no? And the slope, which was less than 1 degree, would have increased to 2 to 3 degrees. All okay? So let's write something about it before we move ahead. Write down continental slope. Steep descent from the shelf. So, what is continental slope? Just a second, guys. Have your eyes here. So, continental shelf, less steep. This is the ocean floor, the original ocean floor. We call it abyssal plain or the ocean floor. So the area connecting the continental shelf and the basin is called as continental shelf. So write down the steep descent from the shelf to deep ocean. And India, we would have the continental shelf. After the shelf, we will have the slope areas. Very good. The third part, they have missed writing here. We can add here. It's called as the continental rise. So once it continental slope ends, suddenly the slope decreases again because there is deposition would come, and here you will have a small hump like. We call it continental rise. So everything that flows through the slope will get deposited here, and there is a decrease in slope suddenly. We call it continental rise. And then starts the original ocean floor, which we call as the abyssal plain or the ocean floor. Abyssal plain. Ocean floor. All okay? So write down abyssal plain. It is deep, flat ocean floor. So that's the definition of a basal plain. It's deep and it's a flat ocean floor. Example, you can give any Atlantic floor, Indian Ocean basin or Atlantic Ocean basin. These are all examples. All okay? Now, after the World War One, when the German made submarines and we started moving into the depth of the oceans, we found out that in between oceans, for example, imagine this is the Atlantic Ocean. Okay, here you have Africa, here you have Europe, here you have North America, and here you have South America. Okay, in between you have a continuous mountain ranges that is existing in between the ocean. We would have studied it when we studied sea floor spreading. Remember? Yes or no? Continuous mountain chain. So what happens is that there is a crack, and from this crack magma rises up, forming new ocean crust. When a new crust is formed here, it will push the older crust in both sides. For example, I come out like this, I form the new crust. Those who were there, I will push them aside like this. Right? Yes or no? So same way, so here you would find the youngest crust of the ocean, and as you move to the sides, you found older rocks. So this continuous mountain chain, which is the longest mountain chain in the world? Yes, we would say Himalayas, but they are on the land. These mountain chains exist continuously for almost 70,000 kilometers. Okay, and in all oceans, Atlantic, Indian, Pacific, you can see mid-Atlantic ridges. So write down. Next is mid-Atlantic ridges. Underground mountain ranges, underwater, not underground, sorry. Underwater mountain ranges. And what type of movement is happening there in the mid-Atlantic ridges? Tell me, what type of continental movement is happening?
Divergent.
Very, very good, champion. So there is divergence happening. That's where the crack is formed. New magma is rising up. It is an example of divergent plate boundary. Very good. Now, can you give me an example of another example of divergent plate boundary that happens on the continent? I have taught you this. Think.
Or the Great Rift Valley.
Very, very good, Siddhant. The Great African Rift Valley, the East African Rift Valley, where Africa is breaking up into two pieces, right? Something like this. And this will be the African plate, and there will be a new plate here, Somalian plate, which is moving away from each other. Diverge. Great work, Siddhant. Okay. Now, mid-oceanic ridges. All of you got this? Now, there is another feature that we have to study is ocean trenches. What are ocean trenches? So, when a continental plate and an oceanic plate or any two plate will come and collide, the denser plate will start subducting and going below the other plate, right? So here there would be a gap, and this would be very, very deep till the plate goes. Such gaps are called as trenches. So when two plates come and collide, the denser plate, if a continent and ocean plate will collide, the ocean plate will always be denser. So the ocean plate will start, it will not come and kiss like this. It will start going down. And this gap will form a trench. And you guys would have known Can you name 3 or 4 trenches?
Mariana Trench.
Very good. We have the Peru Trench, we have the Philippines Trench, we have the Japanese Trench, okay? All of these are trenches. Okay. Now, write down Sunda Trench, ocean trenches, deepest part of the ocean. And what is happening there? Subduction. Mariana Trench and the Sunda Trench. Mariana Trench and the Sunda Trench. All okay? Then, ocean relief, you can also name another ocean reliefs called as guyards and oceanic. So imagine volcanic eruption. This is trench. Okay. Now imagine volcanic eruption happened and it started accumulating and it formed a mountain. And at one point of time, the mountain has come above the ocean floor due to some reason, due to accumulation or due to lowering of the sea level. Can be any reason. Such tips we can call them as islands. Okay. And now when they come above the water, they will start getting eroded by the wind and river waters and all. Water will form in that island, rivers will flow, right? And wind also will start breaking off that tip. And slowly, slowly they'll make it flat. Such flat top mountains are called as guyot, Gyot. Gyot. So when they have to get eroded, they would be above sea surface. And slowly, slowly, when the water level rises, and they might sunk inside. We call them pyramids. So these are the features or the relief of oceans. Okay, guys, any questions before I move on to the next topic? All okay? Great. Now,
Also,
huh,
these forces that erode the island, they
hmm.
are exogenous forces.
Yeah, they are exogenous forces because they can only act above the sea level. When the mountain is above, that's where wind can act. Yeah, we call that sea level as the baseline of erosion. There is another word, write it down. So below this baseline, there cannot happen erosion. Baseline of done. Okay. So now we are going to the second topic, ocean temperature. Right. Ocean temperature. Now you guys tell me. Uh, I'll take Christina for example. Okay. So let's, Christina, are you ready for the experiment? Okay. So Christina, and I tie a big rock to Christina. Okay. And then we drop her into the ocean with a temperature in her hand. And she's going down like this. Bloop, 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 bloop. Now, what will happen to the temperature as we move from the surface to the bottom? Huh? Friends, what will happen?
The temperature will increase.
Okay, very good. So that is the question that we are going to answer. Now you guys tell me, where would be the maximum temperature? Surface, that's what is getting heated, right? So the surface temperature would be maximum. So write down ocean surface temperature, highest at the equator. And same way, when you talk about the ocean in the entire world, more hotter would be in this area, not in equator or just above equator, because equator there is rainfall throughout the year. So it will decrease a temperature. So maybe 5 to 30 degrees, you will find the highest surface temperature. But generalization, we can say surface temperature would be highest in the equator and it would go down as we move towards the poles. So let's come back to this experiment later. Now we'll see the surface temperature when we are moving on the surface of the water. Okay. So maximum temperature would be, we can generally say from the equator, the temperature will go on decreasing. But if you get a question, is the surface temperature maximum at the equator? Because we know in equatorial type of climate, it's warm, every day water evaporates and there is rainfall, so it calms the temperature. So just after 5 degree to 30 degree, you would find the highest ocean temperature. If we have a figure, it would be great. Yeah. So see the darkness, the red darkness, here it is less darker, but here it is more darker. Can you see? On the equator, it is kind of less dark, a little less. Very good. So write down higher at equator 27 to 30 degree and it drops towards the poles. And it drops towards the poles. Then, what are the factors that affect temperature? That itself can be a prelims question or a mains question. And they have asked us, what are the factors that affect ocean temperature? First would be latitude. Lower latitudes, more heat. Higher latitudes, colder. Yes or no? Latitudes. Second, ocean currents. When a warm current will flow, the temperature there will increase. When the cold current will flow, the temperature will. Cloud cover. Simple. If there is a vast ocean and suddenly there is a big cloud cover, sunlight will not pass and the temperature of below that would decrease. It's the same way we feel here. So it's very hot, suddenly a cloud cover comes and you feel, right? Yes. Then mixing of water, cold currents and warm currents coming and mixing together, this also causes change in temperature. So write down factors that cause change in surface temperature: latitudes, currents, cloud cover and mixing. And one thing I again want to remind all my friends here, if this exam is to be cracked, you have to keep writing every time. Okay. So you guys have made notes, you might have notes. Okay, I have notes. Why should I write again? Each time you're writing, your speed is increasing, your handwriting, and you remember better. So the only thing that's going to save you in this exam is your writing skills. Okay. If you've seen that old people and all in their home, they sit in front of the sofa reading the newspaper like this. You guys read newspaper every day? Yes? Online friends, do you guys read newspaper every day? Yes or no? Okay, very good. Can you guys explain any one topic that you read in the last 1 week in detail in UPSC model? Why, where, when, reasons, causes, any one topic in detail? Which one?
I was talking about trade talks between US and Canada.
The trade talks between US and Canada. Okay, very good. What were you saying? PIP. Okay, PIB. Okay. Huh? Deen Dayal Ant Yojana. Okay, very good. So now, if I tell you to write a 200 words answer on Deen Dayal Ant Yojana, can you write it? It's difficult. Usually, no, because when you read, you forget it. Like I had taught you this currents and surface temperatures, layers of the atmosphere, but it's not you. I also will forget it unless and until I write it down, read it 10 times, and that is where you imprint it in your mind. So there is no easier way here other than writing. And I also know it takes a lot of time, but you have to get it done. All okay? Great. Then, shall we move ahead? And how many months is over? You started preparation, my dear friends. How many months are over? 4 months. What about you? Now, what about online friends? How many months are done?
6 to 7 months.
6 to 7 months. Very good. And can you confidently say, like, sir, I have finished this part. Polity, I have finished till Parliament. History, I have done till the first phase of revolution till 1905. Geography, I have done climatology, oceanography. Or economics, I have done till lending or banking systems. Can you guys confidently say that this part is done? Some part of modern history and polity. Rest? So see, there are 9 to 10 major chapters, major subjects, and it's already 4 months you have been. So do you think you are doing justice with the speed that you're working? You can fool anybody, but you cannot fool yourself, right? Guys, do you think your speed is great? No. So this is not part of my work, but I helped students who are very, very interested to finish off. And there is a pattern. I make them write notes. You have to do it by yourself. I'll just give you the next what to do, how to do. And within 3 to 4 months, you can finish off the entire syllabus if you work really hard for 4 months. 4 months, then everything is done. You have time to revise, you have time to work, but it requires lot of commitment and lot of hard work. So if you are interested, I can help you. It's not part of my work profile here, right? Huh? Yeah, I can just guide. It's you have to work, right? But I can guarantee you 3 to 4 months you can finish off. You will have the notes of all the subjects ready, and then you can push. Okay, so you can call me. We'll discuss on that. We'll talk together. I'll not take it part of the class because it's not required here. Those who are interested. Okay. And if you are very confident with your preparation, you're going great, no problem, follow it. It's perfectly okay. I would be very happy for you. But don't be in a imaginary world that, oh, I'm going to the class and then I'm coming, I'm sitting the whole day with books. My preparation is going. No, it doesn't happen that. I am in the library. The library, you're seeing who's sitting nearby, who's coming, who's going. That doesn't work. You require specific targets you finish every day. And that is how you crack this. Okay. So if you are interested, you can contact me. I'll give you my number and we'll work on that. But again, uh, in my experience of 8 years, I can see out of every 100 students who take up this challenge, only 3 finish. and they clear the exam also. And they clear the exam also. Everybody starts, and after 4 or 5 assignments, the number starts dropping because they're not that committed to the cause. And it is okay. If you have lot of money at your home, your father has a business running, enjoy, study little, go take care of your business. But no, if you have to make your entire family stand up, that thing, it's choice. Okay. So the temperature, surface temperature is highest at the equator around 27 to 30, and then it drops as you move towards the, all okay? Then affected by the factors, we have discussed the factors also. Now, surface layer. So if you draw the temperature chart, it would look something like this. This is the ocean surface and this is the ocean bottom. Okay, imagine this is 20 degree, 25, 30, 35 temperature going increasing like this. Temperature. Okay, so the highest temperature would be at the surface, and from there the temperature would slowly, okay, yeah, highest, what, okay. So if this is how the temperature is, the temperature would be highest here on the surface, and it would go slowly, it would start decreasing. At one point of time, there would be a sudden decrease in temperature, and after that point, the temperature almost remains constant. Okay, so this area where the temperature changes maximum is called the thermocline zone. Thermocline zone, sharp drop in temperature. So usually above layer it's slowly decreasing and then there is a sudden change. And at a point then the temperature is almost constant because sunlight cannot reach, right? So it again is constant. And in some books, some places they show at the bottom, sometimes the temperature increases again because if there is a geothermal vent where heat comes up from the ground, sometimes, not everywhere. So surface layer, warm 100 to 400 meters, then thermocline, there is a sharp drop in temperature. Then you have the deep layer where you have cold and stable temperature, cold and stable temperature. All okay? Anybody from Bengal here or anybody who knows Bengali? No? Today I was just in the morning I was practicing Vande Mataram, and in Bengali I was understanding the meaning of the words. Such a beautiful language. All the words are so powerful. I again fell in love with Bengali language. Okay. So sea surface temperature, you can see the surface temperature decreases as we move from the equator to the poles. Clear? And is the temperature maximum at the equator? No. Maximum above the equator and below. Super. All okay online friends?
Yes, sir.
Yeah.
Yes, sir.
That yes was very powerful and it got me all charged up again. Okay. So we studied surface temperature. So two types of, when you talk about temperature, we studied two. First, as we move in the surface from equator to the poles, and second, from the surface to the bottom of the ocean. Vertical, horizontal temperature. So this we call as horizontal temperature distribution. This is vertical temperature distribution. Yeah. Any questions, my dear friends? Come on, we have talked so much about oceans. You might have some. Vande Mataram is Sanskrit? Oh, nice. Yeah, maybe that's making it more beautiful. That's nice. Okay, any questions? Thanks for the info. Any questions, my dear friends, till now? Or any other topics that you want to discuss? We have last 2-3 minutes. I don't want to start salinity because we cannot finish it. Any other question?
Sir,
Yeah.
sir, about at what height do we reach that thermocline there? Or
Uh,
at what depth?
what depth? I think from, I'm not very correct till there, 400 meters to it would be around 1,000 meters would be the thermoclines. Okay, I'll check it and get back to you with the exact number. Good question.
Okay.
Any other questions? Come on. I want at least one question from Palak, Rimin, and Christina. And Mahesh also. Mahesh, right? No. Suresh. Sorry. Suresh. And one question from Suresh also.
So you said about some challenge, right? So
Yeah.
can you tell us how to cover it? Like cover
Okay.
the syllabus?
Okay. So this challenge is about writing notes. Okay, so I'll give you one NCRT or one book, and I'll give you a limited time, 2 minutes, 2 days, 2 days to finish off. You read it, you make it into notes. Notes in the sense not like we write notes. Notes in the sense as if you are writing notes to take it to exam to copy. You guys would have used bits and all to copy in exam, right? Yeah, those who have done it, it would be best for them. So this note should be very, very comprised. So I usually, after a lot of work, I came to this pattern. I take an A4 sheet into 3 columns and I write the notes very, very shortly. I would never write a single word that I know. For example, if I give you to write the notes of geography, NCRT 6th standard, you would start writing. Okay, there are 8 planets, Mercury, Venus, Earth, Mars, then you will draw the diagram. You know all these things. You don't need to write that. The shape of the earth is geoid. You know, you don't have to write that. Because when you are taking a bit to copy in the exam, will you write the things you know? No, you'll only write the things you don't know, right? And you would write it in minimum words. For example, if I am talking about Indonesia and I am telling as you move from east to west, the density of the forest decreases, right? So I will not write that. I'll write forest density decreases east to west. Minimum words which I can have one NCRT. I'll show you, maybe tomorrow I'll show you my notes where I have 5 chapters of geography NCRT in one page. 5 chapters. So one NCRT would be coming in 3 or 4 sheets like this, and 2 days when you do this, you achieve something that motivates you. You have improved your reading skills, which is important for prelims. You have improved your writing skill, which is important for mains. And within 2 days, when you see the notes, that motivates you. Yeah, I've done something. Let me get to the next challenge. So, second NCRT or second book, what we plan. And if we can finish this off like this for 3 months, you guys can do it. Done. Entire syllabus would be there in form of such notes, and then you have to read it 10 times while walking, while going on bus. You can read them, and it would take 5 minutes to revise one NCRT once. Everybody wants, so UPSC is a 2 mountain. The first mountain is very tough. It is writing. There is no water, there is no trees. It's very tough. But if you only climb this, then the second mountain is easy. You have an escalator. You just have to read it 10 times. And here you have the flagpole. Like Mario. So it's a big challenge. And if you feel that within 4 or 5 months you have not achieved enough, This is the time to fight. And if you're very happy, comfortable in your zone, going good, enjoy life. I love enjoying life. Don't worry. If your father has a business, 3,000 crore business setup, you just have to go and take up after some time. It's okay. If your father is a big officer and has 100 crores black money at home, okay. Enjoy. Go out, have friends, make girlfriends, make boyfriends. But if the entire family is dependent on you and you want people to salute you when they see you, call you to your home, sir, aao mere ghar aao, come to my house. Then you have to work, sweat out for 1 year. There is no easier way than this. So those who are interested, you can contact me. I'll help you with the task. Okay. And don't expect me to come to tell you, do this, do this, do this. No, that's not my job. You should come, sir. I finished this. What should I do next? Sir, you told me to do it in 2 days. I've done in 1.5 days. Yeah, what should I do next? That shows up. You go. You can't expect me to come the third day. या क्या हुआ बेटा कर लिया? Because people who don't have that passion can never clear this exam. They might do bigger things in life. They might become a big business tycoon. I'm not challenging their skills or ideas. I'm saying this cannot be done with an slow attitude. So I hope this class was a bit motivating for you guys. You guys got charged up. You have to charge yourself every day. I cannot come up also. So get going, get working. All the best. See you in the evening. I think you guys would be there in the evening session also, right? Okay.
Yes, sir.
Aloha. Bye bye. Take care.
Bye, sir.
Bye. Thank you.